Hello class, hope you're all having a good week so far. This is video one out of what is going to be a series of videos that will hopefully clarify some of the database concepts that we need to understand data warehousing and also some of the books that we've been reading. So a lot of the concepts that we're talking about in the data warehousing class so far are about how to structure data so that it's more easy to query for analytics users and for human consumption, right? And so we've talked a lot about the difference between normalized databases that are for transaction processing, that are optimized for writing and updating data, right? And then there are denormalized databases that are optimized for human consumption and human querying. And I think where part of the gap is around this structure of databases and what does it mean to query a database and how can it be easy and how can it be hard. And so I hope that I will kind of illustrate these concepts to you. And I was trying to think of where is a good place to start. And so I think we should just start at the beginning. So I want you all to walk out of this class with the SQL skills that you need in order to be an effective analyst. So one of the statistics that I like is for data science work and for data scientists in general, the general consensus is that they spend around 80% of their time getting and cleaning their data, getting it ready for analysis. And so what does this actually mean? And I think in order to illustrate why this can be challenging for data scientists or anyone that's building reports or doing analyses, I think to understand why it's challenging, we need to understand what databases are and how they're typically created and structured. And hopefully when we go over these kind of essential concepts, you'll be able to get an appreciation for how complex it can be to get data from a database, especially a normalized database, and why it might be a good idea to do the work once where we get the data in the right format and we clean it. And then once we do that on the database, the job of the analytical or reporting or data scientist user becomes easier. So we would be reducing, hopefully, that amount of time and effort that it takes for them to get the data that they need. So a lot of times this process is the bottleneck for somebody that's wanting to use the data that's generated in a business. And so us as data warehouse professionals, we can simplify their job and help to reduce that bottleneck and get a faster time to analytics. Okay, so this is the concept behind data warehousing. So let's kind of go through from the beginning. So we're talking about doing data warehousing within a relational database management system. And for this video, we'll be talking about creating database objects and inserting data into database tables. Okay, so this is the process of creating a place that we can put data for people who might want to use it for analytics. Okay, so these are all pretty relevant skills for people that might be interested in getting the data and putting it someplace consumable. So what is a relational database management system? A lot of times it's abbreviated RDBMS, or you'll hear DBMS, or a lot of times DB. So these are all what people are generally talking about when they're talking about a database. And the Wikipedia page for relational database management system is pretty good, actually. It mentions the inventor, Cod at IBM, not all that long ago. What I like about this page is the general structure of a relational database management system. Okay, so this is kind of a conceptual model of a database server. So within a server, there are different models and processes that go on that help to optimize the storage and retrieval of data. So like any computer, there is a disk that's like a hard drive storage, and then there's memory, which on our computers would be like RAM. So the data in a database is stored on a disk in tables that have rows and columns. And then a database server can generate indexes based on the tables. So I won't go into the technical details of how indexes work, but it's basically a process where the server goes and will organize data in a table and label it with an index so that it's faster to retrieve. So this is an optimization process that typically is the concern of people who are database administrators, kind of working more on the technical hardware backend of a database. It also captures things like logs, which are important if you have protected data that they may be subject to audit to see who's accessing what. And then control files, which I'm not real sure what that is because it doesn't much matter for our job as data warehousers. So within memory, that's where things like SQL statements happen. Whenever you enter a SQL statement, which could be like a query to retrieve data, the database generates a plan for how it's going to go retrieve data. So if you have a SQL statement that involves 5 different tables, then the database server is going to come up with the most efficient plan to retrieve that data. And there are a few ways that you can generate the plan from SQL Server Management Studio if your database queries have performance issues. All right, I think that's just about all we need from this model. So let's go ahead and move on. And so within a database management system, are several or one or more databases. So like our SQL server that we're working on is a database management system. It is a single server that contains many different databases. So we can look at it here, actually. So here's our server. This is the only server I'm connected to. Then it has all of these things. The primary objects within a server are databases. And then within each database, they have a lot of other kinds of objects. Most relevant to us are like tables, which are the unit of storage for data. So each database has, it can contain multiple schemas and also tables. The default schema for every database, in Microsoft SQL Server at least, is DBO. So if you do not create your own schema, then any table you create will just default to DBO, which is okay because we don't always need schemas. It's just a way to group tables for security or organization reasons. So schemas are not actually necessary for the job of storing and retrieving data, but they can be kind of helpful just to group tables and maybe manage security. Tables are collections of rows and columns. So within any table, you may um, crack it open in SQL Server Management Studio to view the columns, and then it will tell you some information about each of the columns. So this would be like metadata about the columns that tells you what data type they have. And an optional attribute of columns is you can specify whether it is nullable. So you can see in this particular error log table, this error severity column is an integer, so it only contains whole numbers, and it is nullable. So this may be null in SQL. Null means that there is no value. Okay, so it's blank, essentially. Um, and then username has a more complex data type. It looks like it's some sort of system name data type. And then it is a variable character length 128. So data types determine what kind of data can be stored in the table, and it also determines how the database stores the data. So for fields like in varchar with some number there, what that means is that any kind of characters can be stored up to 126 characters long. But with this particular data type, with variable character, that means that if I enter some data in it that is only 10 characters long, then whenever it's stored in the table, the database is going to compress the amount of memory or the amount of storage space that's going to be needed to store this down to 10 characters. Okay, so if you don't use variable character, but if we just said this is a string length 126, and then we go and enter a 10 character value into this column, then the database is going to be storing 126 characters worth of space, but most of it's going to be blank. So variable character is kind of an efficient way to store character or string data, so like text, within a database. And then, of course, we have integers. There are a lot of other types of data types. I left a link here in the OneNote for you, so you're welcome to explore this. There are a lot of data types that are rather obscure and that we may not be using. But you can see there is a variety of data types for numbers, date and date time, which are pretty significant for data warehousing. For example, whenever we start to get into ETL and we decide we want to dump a bunch of data in a table periodically, each time we're adding data to the table, we need to figure out where we left off. So we might look for some kind of column that has some timestamp of when the data was generated so that we can add only new data. We have our variable character, and then there's in varchar. These have some subtle difference, but they are, for intents and purposes, interchangeable. We have binary strings, which would be a true or false type value. And then there are some other interesting data types that I am not really interested in for these purposes. This is also the official Microsoft documentation, by the way. It has a lot of useful documentation. So hopefully you will have enough of an understanding by the end of this class to be able to navigate this a little bit. But this data types is pretty useful. Okay. So when we're talking about a relational database, so a relational database is a collection of tables that are stored in a database. And then this relational part means that we can define relationships between data. One reason why we would want to do that is perhaps we want to introduce some kind of constraints on what kind of data can be written. So there was an example over here in AdventureWorks. In sales territory. Okay, so you can enforce some constraints on what kind of data can be entered by using primary and foreign keys inside of your tables. So what are these things? We can see in a lot of these tables, we talked about the data type and whether they're nullable, but there's also this PK here, which means primary key, and FK, which means foreign key. And we haven't really talked about what these are in detail, so let's explore this a little bit. And I will pull up the documentation here because it's pretty good. So a primary key is a unique identifier for a row. So within a table, you have all these different columns, all these attributes that you're capturing. And when you create a row, you're adding some values to all of the columns in a table. And you can add a unique identifier, for example, customer number that wouldn't uniquely identify a person as a customer. And then you can designate that unique identifier as a primary key. So a primary key is used by a database for indexing so that it can more efficiently retrieve information from the table. And then a primary key is also used to control what foreign keys are available. So a primary key uniquely identifies a table. In sales territory, the territory ID uniquely identifies each sales territory. So we can look at it here. So that's annoying. Okay, here, let me turn on Do Not Disturb real quick. Focus assist. Great. Okay, we see our unique territory IDs along with the corresponding name. We also see that territory ID here is a primary key, uniquely identifies each row in this table. And then we see that country region code is a foreign key. So what that means is that this is the primary key in another table. So I like to think of the foreign key as it's borrowing the primary key from a different table. So this creates a relationship, right? So we have the sales territory, and then the sales territory has some relationship to country region code because this unique identifier for country region code is embedded within the sales territory table. Okay, so this within the database creates a relationship where whenever we are entering new data into sales territory, the country region code, because it's a foreign key that's related to the primary key of another table, if we enter data into this table, the country region code has to exist in the table where that is a primary key. This concept is called referential integrity. So this means that we would not be able to populate this column with invalid data. And we can kind of, let's just see what happens if I try to alter one of these foreign keys to some value that I know is not correct. So what should happen is I should get some kind of error that tells me that referential integrity is being violated. See, so there is a constraint on this table because this is a foreign key that there needs to be a primary key that exists in the corresponding table. Okay, so that update will not work because that's not a valid country region code. So let's see if we can find where country region code might be. So it's a foreign key that must be coming from probably this country region table. Yeah, so here is the country region code designated as a primary key, which just has the name and modified date. And we can look at these to see all of the valid values here. So this primary key, foreign key relationship is useful for data integrity, right? So we cannot, or a person or a process that is updating or inserting data into a table cannot enter invalid data. This is really useful whenever you have a database that is being written to a lot, right? So we've talked a lot about like transactional databases or operational databases that are optimized for writing and updating data on a very granular level. So these primary key, foreign key relationships and the enforcement of referential integrity helps make sure that this data is valid and accounted for. So I can't enter 12 in a country region code. Okay, these are very relevant for transaction processing type databases. And I don't see them that much in data warehouses because a lot of times when we're combining multiple systems that might have different kinds of country region codes, um, it can create some overhead to create these relationships, especially if you're working with messy data. But it is good to know that they exist and to know generally how they work because this is really how these implicit relationships are formed between tables is through the primary key, foreign key relationship. Um, and these can also be used you can visualize relationships between tables. So at some point I showed you guys an AdventureWorks um, entity relationship diagram. So that's one way to visualize the relationship between tables using a fairly common notation. I'll see if I can find that. Yeah. So within this diagram, this shows all the tables that are in the AdventureWorks database. And each of these relationships between the different tables is based on the primary key, foreign key relationship. Oops. So I'm trying to make this bigger for you guys and failing. But if you look closely, you can see that each one of these tables that has a relationship to another one, let's see if we can find the one we were just looking at. Please hold. Okay, found a good example. Trying not to derail myself by going on a tangent here. So bear with me. So here is an entity relationship diagram. This visualizes the relationships between different tables that you would find in a database. You can see here is a booking table, has all of these columns, and then some of them are designated as primary key or foreign key. So for the booking table, booking ID is the unique identifier, and it also has a passenger ID, booking status ID, ticket type, flight, all these different foreign keys which point to different tables. So what this does is that it creates constraints where we cannot enter a passenger ID unless it already exists in the passenger table with a passenger ID primary key here. Okay, so that would be referential integrity, right? And this also allows us, as an analyst, if we want to look at bookings that a passenger had, we would be able to combine these tables to see for every passenger, give me the booking ID where that passenger ID is in this table, and then we could combine that with the passenger information if we want. Okay, so an entity relationship diagram is kind of a useful way to visualize the tables that are in a database and the relationships between them. There is some notation here that is fairly simple that indicates the nature of the relationship, the cardinality between these tables. So you can see it on this line here. So this means there's some kind of relationship between this table, and it also tells us some details of the relationship. So the way you read this is, so first off, there's this little empty circle with the crow's foot, is what this is called, means that a passenger can have 0 or many bookings. So whenever you're reading it, you go from passenger, you follow the line, and you say it has this relationship to the booking table. So a passenger can have 0 or many bookings. I guess you could read it more specifically. A passenger makes 0 or many bookings. And then a booking belongs to one passenger. So that's what these symbols here mean. There could also be a little 0 or a little empty circle over here, which would mean that a booking has 0 or 1 passenger. You could also have 2 lines here, which means a booking has 1 and only 1 passenger. So this is an entity relationship diagram, also called an ERD. It can have different kinds of notation. This is crow's foot notation. I like it because it's pretty intuitive. It tells you whether a booking belongs to 1 or 0 or many passengers. In this case, it's 1. And so it tells you kind of the direction here. So for a given passenger ID, we would expect to find 0 or many instances in booking with their passenger ID. Same relationship with some of these other tables. So a booking has 0 or many payments. And then each payment is related to 1 booking. Bookings are classified by ticket type. Each booking has 1 and only 1 ticket type, and a ticket type specifies a booking. So that's an entity relationship diagram. And hopefully that clarifies the foreign key, primary key relationship, and also explains a little bit about why it's called a relational database management system. Okay, so these are explicit relationships that enforce that referential integrity, so it dictates what kind of data can be entered here. So on the transaction side, very relevant. On the reporting and data warehousing side, maybe not quite as relevant because a lot of times we're working with messy data And we might have a booking with an invalid passenger ID, um, or perhaps with a passenger ID that doesn't exist in the table for some reason. So these are kind of common issues that make it a little harder to use primary keys and foreign keys. But hopefully you understand generally what those are now and the concept of referential integrity. Now that we've covered the different stuff in a database, let's talk about creating objects. Hopefully this will clarify some of what we did in our very first lab, which in retrospect maybe should have been our very last lab for the class because we were working with some advanced concepts. So let's unpack this a little bit. We're going to start at the beginning with creating a database. From there, we're going to create a table, a couple of tables, and we're going to insert data into them. So what we're doing here is the beginning of creating a database for perhaps a transactional purpose. So we're going to have a customer table and we're going to have a sales territory table. So these are versions of tables that we might find in the AdventureWorks transactional database, but kind of in embryo. So the purpose here is to show you different ways that we can insert data into a database. So we are writing data to the database. And there's a few ways we can do this. This is relevant for transaction processing because each time you make a payment at a cash register, it's getting stored in a database somewhere with this command. So there's going to be an insert into some kind of table, and it's going to specify the values. So it could tell your credit card number, maybe if you have loyalty points or something like that, then it might have product and quantity. And so it would be inserting a single line into a database. And then when we start talking about data warehousing, we are very rarely going to be inserting line by line values like this. A lot of times we'll be taking values that already exist in a transactional database somewhere, and we might be doing some kind of bulk insert, which we'll be doing here. So let's unpack this a little bit. This is all in a single SQL file because I want to share it with you guys so that you can play with it if you want. So the very first thing that I did is to create a database called DemoDB. I ask that you probably don't do this because this is a real database that we're using for the class. We don't really want to create a lot of clutter and mess. So if you decide to mess with this, just skip the step of creating a database, but feel free to create different kinds of tables. In DemoDB, okay, the next statement here, so after I create a database, I have this statement that says use DemoDB go. You can put this at the beginning of any SQL statement, and this basically points whatever code you're about to run to the database. So I'm connecting by using this statement to the DemoDB database, which means when I run this create table statement, it's going to be created in DemoDB. Okay, so this is how tables are created originally. So you use a command that says create table. Here, I just made this up. I said create table customer. I specified a customer ID as an integer, customer name as variable character, max length 50, territory ID as an integer, and then customer state as variable character with max length 2. And I just ran this. It said it was completed successfully. And now in DemoDB and tables, I think it needs to be refreshed. We should be able to see dbo.customer. So now we have an empty shell of a table. We haven't inserted any values into it yet because I just highlighted and ran this create statement. So whenever you're, for example, in a data warehouse, whenever you're moving data, you need to create an empty shell of a table that has the correct data types of the data that you intend to insert into it. So if we're moving and aggregating data or integrating data from an operational source system to a database somewhere else, we're going to want to create a landing place for it. So that's what this is. So now let's put data into it. You all should be familiar with the create table and insert values statements because we used this in our first lab for you to create your tables that had your group membership. And we also created a empty product table that we dumped data into with SSIS. So this will insert 4 rows with these values. So each value is separated by a comma, which means that it's stored in a different column. So the very first value I'm entering here, 1, is going to be stored in the customer ID column. The second value, Freud, is going to be stored in cust name. 1 is going to be stored in territory ID. And then AL is going to be stored in cust state. All right, so I'll go ahead and run that. Please hold. All right, as a testament to how seldom I actually insert values, my syntax was completely wrong. So I fixed it here. If you insert multiple rows, it needs to be contained. Each row needs to be contained by parentheses and separated by a comma. So this worked. Also, I made the mistake of having my cust state not in single quotes. It's a string value. So in order to designate it as a string value, it needs to be in single quotes here. All right, so this worked. You can see 4 rows affected, and then we can go query this table, say select top 1000. It should give me 4 rows of what I just inserted. All right, so that's a very manual process for populating tables with data. And this might be relevant if we, in a data warehouse, maybe we have a list of valid customer states and we want to add one for Puerto Rico or something. We might insert a new record there. But generally, tables can be populated line by line using an insert statement. So whenever you're making a transaction or anything that would affect a single row in a table, like in an operational database, they're running probably thousands. They could be running thousands of insert statements all the time. So constantly updating one row at a time within the different tables. A data warehouse, we're generally doing more bulk operations. So this insert into statement, it can be used for some of the smaller tables, like a dimension table that, like I said, might have valid names for states or something like that, some kind of smaller dimension table. We would use an insert statement. So that's one way to put data into a table. Another way to put data into a table is with a select statement. So here we're going to create a table called sales territory. I intentionally left this error because I wanted to show you why sometimes columns have brackets. So if I try to execute this, it's going to say group is, incorrect syntax near the keyword group. So you can see group is a SQL keyword Because we use group for aggregated functions, you can see it's highlighted blue in SSMS, which means that it's a reserved word. So we should really avoid naming columns group or select or name because those are reserved SQL keywords. But I was trying to mimic an AdventureWorks table, the sales territory table, and you can see they have a column called group. So if we have to use a reserved keyword, we can explicitly say that this is a column by putting it in brackets. We're going to need to do the same thing here for name and also group. Okay, so now SQL knows that I'm talking about the group column and not the group SQL reserved word. Whoops, need to highlight create table. Okay, the whole thing's highlighted, so now it should run. And now I should have a sales territory table here in DemoDB. So I'll just refresh tables. There it is, empty sales territory table. Have not added any data to it yet, but you can see that it has those columns that we just created. And here I added not null just to show how you can do that. Okay, so now let's populate this table with some data. So here, we're not doing insert values, and we're not explicitly stating what each row's value should be. This is very tedious. Instead, we're going to move a bunch of data that is in the sales territory table in AdventureWorks into our sales territory table that lives in DemoDB. So we're doing this, we're saying insert into sales territory. The next question is, what are we inserting? And we are inserting the results of this query. I can just highlight this query and run it. So this is selecting these 3 columns from this table. Because this is in a different database, so we are connected and working in DemoDB, I need to specify that it's coming from the adventureworks.sales.sales territory table. I believe it will throw an error. If I try to run just this select statement without specifying the database, it's probably going to say it's not found. Yeah, invalid object. So we need to explicitly specify that it's coming from adventureworks.sales.sales territory. And you can see brackets are almost always optional unless there's a reserved SQL keyword or if there are special characters like spaces in the names of columns or other database objects. Okay, so we saw the results of this select statement. And now what this statement is going to do is it's just going to insert those results that you see below into the sales territory table that we created. So I execute that and it inserted all 10 rows. So now we can go look at it and it should look the same. Oops, I double clicked on it, but you can see that they're all there. Another important thing to consider is that if I run this again, it inserted 10 more rows. So now I'm going to have 20 rows with a lot of duplicate data. See that? So whenever we are adding data to database objects, we kind of need to be careful about running commands that manipulate data multiple times. So it's really easy to accidentally populate a table with a bunch of junk and redundant data that's wasteful. I saw this in a few cases whenever we were doing the exercise with SQL Server Integration Studio. If you recall, we created a product table, and then we were inserting data from the AdventureWorks, or no, we were inserting data from a CSV file into a product table, and several people ran the SSIS package and then ran it again and ran it again. And so each time that was run, the SSIS package that we created was essentially selecting the information that was from the CSV file. And it was in the background running a statement very similar to this. So it was inserting into the product table, and then it was selecting everything within that file and dumping it in there. So whenever you're doing insert into, be careful about running it more than once, because once the data is in there, it becomes a little bit difficult to take it out. A lot of times it can be easier to just drop a table and recreate it. So we need to be a little bit careful. Okay, I think that is it for this very first tutorial. Hopefully that answers some questions about things that you were not already aware. In the next video, I'm going to expand on this statement right here. Now, we talked about creating empty tables and populating them with data. But now let's talk about how we can manipulate data, which is going to be done within a select statement. So if we're taking data from a source, we're transforming it in flight and then having it land somewhere else for people to look at, we're going to be manipulating data mostly within a select statement. And then we may be inserting that into some table for consumption. So there's a lot we can do in the select statement, like combining data. So in the next video, I plan on covering querying data, filtering data, aggregating data, combining data with joins, and then changing data with case statements and also update statements. So that's going to be in the next video. So those combined with this creation of objects and inserting data into tables is going to get us to where we are able to effectively manipulate data and also combine a lot of these key concepts to do pretty much all of the things that are talked about in the data warehouse toolkit, which would be, for what you're reading about now, slowly changing dimensions. We would be able to create a table that has territory ID, territory name, group, and then we might add a valid from and valid to date, for example. And so that way, if our territories change, we would be able to change them, but also preserve the historical information if we ever needed to go back in time and look at what the old territories were, or if we needed to roll up sales transactions or customers according to the old territory scheme. So let me know if this was helpful to you. Let me know if there's something else that I ought to cover more in depth. I really appreciated the feedback and the suggestion to create these videos. I hope that it's valuable to you, and I hope that this information here and my rambling explanation helps answer some questions. All right, thank you guys. Hope you're having a good Wednesday. I will start working on the next video with select statements and querying, filtering, aggregating, changing data. Hopefully you'll learn something new there, and hopefully that will make you feel a little bit comfortable for our next survey of lostness. Thank you guys. See ya.